Welcome. Today we're diving into the fascinating world of number systems. Whether you're in 7th or 8th grade, understanding number systems is essential for building a strong foundation in mathematics. Number systems are the way we represent and work with numbers in different forms. From the numbers we use every day to those used in computers, number systems are all around us. In this video, we'll explore what number systems are, why they matter, and how they help us solve problems in real life. Let's begin our journey by understanding the basics and setting the stage for deeper learning. Number system is simply a way to express numbers using a set of symbols and rules. Think of it as a language for numbers. Just like we use letters to form words, we use digits to form numbers. Different number systems use different sets of digits and rules. For example, the system we use every day is called the decimal system, which uses 10 digits from 0 to 9. But there are other systems too, like binary and octal, which we'll learn about soon. Understanding number systems helps us communicate and calculate more effectively, especially in math and technology. You might wonder, why do we need different number systems? Well, number systems make it possible to represent and work with numbers in various ways. For example, computers use the binary system while we use the decimal system in our daily lives. Number systems help us count, measure, and perform calculations. They also allow us to solve complex problems, store information, and communicate data. Without number systems, it would be difficult to organize and understand the world of numbers. That's why learning about them is so important for students like you. There are several types of number systems, each with its own set of rules and symbols. The most common ones are the decimal, binary, octal, and hexadecimal systems. Each system is used for different purposes. For example, the decimal system is used in everyday life, while binary is used in computers. Octal and hexadecimal are also important in computer science. By understanding these systems, you'll be able to solve a wide range of mathematical and technological problems. Let's take a closer look at each type. Decimal system is the one we use every day. It's also called the base 10 system because it uses 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Every number you see around you, from your age to the price of a snack, is written in decimal. The decimal system is easy to use because it's based on powers of 10. Each place in a number represents a different power of 10, making it simple to read and write large numbers. Let's see how this works in practice. The decimal system, each digit in a number has a place value. The value of each digit depends on its position. For example, in the number 345, the 5 is in the ones place, the 4 is in the tens place, and the 3 is in the hundreds place. This system of place value makes it easy to understand and work with large numbers. Place value is a key concept in all number systems, not just decimal. Understanding place value helps you add, subtract, multiply, and divide numbers more easily. Now let's talk about the binary system. Binary is a base 2 system, which means it uses only two digits, 0 and 1. This system is used by computers to process information. Each digit in binary is called a bit. Even though it seems simple, binary can represent any number just like decimal. Computers use binary because it's easy to represent two states, on and off. Understanding binary is important if you're interested in technology or computer science. It's like in the decimal system, binary numbers have place values. But instead of powers of 10, binary uses powers of 2. For example, the binary number 101 means 1 times 4 plus 0 times 2 plus 1 times 1, which equals 5 in decimal. Each place in a binary number represents a different power of 2, starting from the right. This makes binary a powerful tool for computers, as it allows them to store and process data efficiently. The octal system is another type of number system, and it's based on 8 digits, 0 to 7. That's why it's called base 8. Octal is used in some areas of computer science, especially when working with binary numbers, because it's easier to convert between octal and binary. Each place in an octal number represents a power of 8. While you may not use octal every day, it's important to know about it, especially if you're interested in computers. The octal system, each digit's value depends on its position, just like in decimal and binary. But here each place represents a power of 8. For example, the octal number 25 means 2 times 8 plus 5 times 1, which equals 21 in decimal. Understanding place value in octal helps you convert numbers between different systems and solve problems more easily. It's another example of how place value is a universal concept in number system. Hexadecimal system, or base 16, uses 16 symbols, 0 to 9, and the letters A to F. Hexadecimal is widely used in computer science because it's easy to convert between binary and hexadecimal. Each place in a hexadecimal number represents a power of 16. For example, the hexadecimal number 1A means 1 times 16 plus 10 times 1, which equals 26 in decimal. Learning hexadecimal is useful if you want to understand how computers store and process data. Hexadecimal, each digit's value depends on its position, just like in other systems. But here each place represents a power of 16. For example, the hexadecimal number 2F means 2 times 16 plus 15 times 1, which equals 47 in decimal. Understanding place value in hexadecimal helps you work with large numbers and makes it easier to convert between number systems, especially in technology and programming. Let's compare the different number systems we've learned about. The main difference between them is the base, or the number of digits they use. Decimal uses 10 digits, binary uses 2, octal uses 8, and hexadecimal uses 16. Each system has its own strengths and is used for different purposes. By understanding the similarities and differences, you'll be able to switch between systems and solve a variety of problems. Now let's learn how to convert a decimal number to binary. The process involves dividing the number by 2 and keeping track of the remainders. For example, to convert 13 to binary, you divide by 2 repeatedly and write down the remainders. When you read the remainders from bottom to top, you get the binary number. This method helps you understand how numbers are represented in computers. Convert a binary number to decimal, you use the place values of each digit. Multiply each digit by the corresponding power of 2 and add them up. For example, the binary number 1101 is 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1, which equals 13 in decimal. This method helps you see how binary numbers work and how they relate to the decimal system. To convert a decimal number to octal, you divide the number by 8 and keep track of the remainders. For example, to convert 25 to octal, you divide by 8 and record the remainders. Reading the remainders from bottom to top gives you the octal number. This process is similar to converting decimal to binary, but you use 8 instead of 2. To convert an octal number to decimal, multiply each digit by the corresponding power of 8 and add the results. For example, the octal number 31 is 3 times 8 plus 1 times 1, which equals 25 in decimal. This method helps you understand how octal numbers work and how to use them in calculations. Convert a decimal number to hexadecimal, divide the number by 16 and keep track of the remainders. For example, to convert 47 to hexadecimal, divide by 16 and record the remainders. Use the letters A to F for remainders 10 to 15. Reading the remainders from bottom to top gives you the hexadecimal number. This process is useful in computer science and programming. Convert a hexadecimal number to decimal, multiply each digit by the corresponding power of 16 and add the results. For example, the hexadecimal number 2f is 2 times 16 plus 15 times 1, which equals 47 in decimal. Remember to use 10 for A, 11 for B, and so on up to 15 for F. This method helps you understand how hexadecimal numbers work and how to use them in technology. Convert binary to octal, group the binary digits into sets of 3 starting from the right, then convert each group to its octal equivalent. For example, the binary number 110,101 can be grouped as 110 and 101, which are 6 and 5 in octal, so the octal number is 65. This method is quick and useful in computer science. To convert octal to binary, write each octal digit as a 3-digit binary number. For example, the octal number 65 becomes 110 and 101 in binary, which is 110,101. This method makes it easy to switch between octal and binary, especially when working with computers. Convert binary to hexadecimal, group the binary digits into sets of 4 starting from the right, then convert each group to its hexadecimal equivalent. For example, the binary number 101,111 can be grouped as 10 and 1111, which are 2 and F in hexadecimal, so the hexadecimal number is 2F. This method is commonly used in programming. To convert hexadecimal to binary, write each hexadecimal digit as a 4-digit binary number. For example, the hexadecimal number 2F becomes 10 and 1111 in binary, which is 101,111. This method is fast and helps you work with large numbers in computer science. Number systems are not just for math class, they're used in real life too. For example, digital clocks use binary, computers use binary and hexadecimal, and some old calculators use octal. Understanding number systems helps you see how technology works and why certain systems are used in different situations. It also helps you solve everyday problems more efficiently. Computers rely heavily on number systems, especially binary and hexadecimal. Every piece of data in a computer, whether it's text, images, or music, is stored as a series of zeros and ones. Hexadecimal is used to make long binary numbers easier to read and write. By learning about number systems, you're taking the first step toward understanding how computers work. Even outside of computers, number systems play a big role in our lives. We use the decimal system for money, measurements, and counting. Sometimes you might see Roman numerals on clocks or in books. Each system has its own purpose and history, showing how humans have always found ways to represent numbers. Roman numerals are another example of a number system. Instead of digits, they use letters like I, V, X, L, C, D, and M. Roman numerals are still used today on clocks in book chapters and for special events. Learning about Roman numerals helps you appreciate the variety of ways people have represented numbers throughout history. Besides Roman numerals, many ancient civilizations had their own number systems. The Egyptians, Babylonians, and Mayans all used unique ways to count and record numbers. These systems show how creative humans have been in finding ways to represent and use numbers. Studying these systems gives us insight into history and mathematics. 0 is a special number in number systems. It acts as a placeholder and makes it possible to write large numbers easily. Not all ancient number systems had a symbol for 0, which made calculations harder. The invention of 0 was a major breakthrough in mathematics and made modern number systems possible. Negative numbers are also important in number systems. They allow us to represent values less than 0, like temperatures below freezing or debts. Negative numbers are written with a minus sign in front. Understanding how negative numbers fit into number systems helps you solve a wider range of problems in math and science. Fractions and decimals are ways to represent numbers that are not whole. In the decimal system, we use a decimal point to separate whole numbers from fractional parts. Fractions use a numerator and denominator. Understanding how to work with fractions and decimals is an important part of mastering number systems. Irrational numbers are numbers that cannot be written as fractions. Examples include pi and the square root of 2. These numbers have endless, non-repeating decimal parts. Irrational numbers are an important part of the number system and appear in many areas of math and science. Rational numbers are numbers that can be written as fractions where both the numerator and denominator are integers. This includes whole numbers, negative numbers, and decimals that end or repeat. Rational numbers are a key part of the number system and help us solve many types of problems. Natural numbers are the numbers we use for counting 1, 2, 3, and so on. They are the most basic numbers in the number system. Natural numbers do not include zero or negative numbers. They are used in everyday life for counting objects, people, and more. Whole numbers are like natural numbers, but they also include zero. So whole numbers are 0, 1, 2, 3, and so on. Whole numbers are used in many areas of math and everyday life, such as counting and measuring. Integers include all whole numbers and their negative counterparts. So integers are -3, -2, -1, 0, 1, 2, 3. Integers are used to represent quantities that can go below zero, like temperatures or bank balances. Real numbers include all the numbers you can think of: natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Real numbers can be positive, negative, or zero. They are used in almost every area of math and science. Imaginary numbers are numbers that involve the square root of -1, written as I. They are used in advanced mathematics and engineering. While you may not use imaginary numbers in everyday life, they are important in higher-level math and science. Let's quickly review the different types of numbers. Natural numbers for counting, whole numbers including zero, integers with negatives, rational numbers as fractions, irrational numbers with endless decimals, real numbers as all of these, and imaginary numbers for advanced math. Each type has its own use and importance in mathematics. Understanding number systems is crucial for success in math and science. They help us solve problems, communicate ideas, and understand the world around us. Number systems are the foundation of mathematics, and mastering them opens the door to more advanced topics. The best way to master number systems is through practice. Try converting numbers between different systems, solving problems, and exploring how number systems are used in technology. The more you practice, the more confident you'll become in using number systems. When working with number systems, it's easy to make mistakes like confusing place values or using the wrong base. Always double-check your work and make sure you're using the correct method for each system. With careful practice, you'll avoid common errors and improve your skills. Here are some tips to help you learn number systems. Start with the basics, practice regularly, use visual aids, and ask questions if you're unsure. Remember, everyone learns at their own pace, so don't be afraid to take your time and review concepts as needed. There are many resources available to help you learn more about number systems. Textbooks, online videos, and interactive websites can provide extra practice and explanations. Don't hesitate to explore these resources to deepen your understanding and strengthen your math skills. Congratulations, you've learned about number systems, their types, how to convert between them, and their importance in daily life and technology. Remember, number systems are the building blocks of mathematics. Keep practicing, stay curious, and you'll continue to grow your math skills. Thanks for watching, and see you in the next lesson.